For decades, humanity has searched the heavens, straining radio dishes and combing through endless static, waiting for a whisper from the stars. But then something arrived. Something that didn't just pass silently through the void, but slowed as it drew near. An object cataloged as 3I/Atlas, a name that now carries both awe and dread. Official reports said its glow should follow the predictable rules of physics, nothing more than sunlight striking frozen dust. Yet within a mere 4 weeks, its brightness surged 5 times beyond expectation, as if the object itself were defying the script written for comets. Spectrographs revealed something even stranger. Metallic traces embedded in the coma, the ghostly cloud of gas and dust surrounding its core. Not random elements drifting in space, but metals normally forged in furnaces, shaped rather than found. Against everything astronomers know, 3I/Atlas refused to behave like a natural wanderer. Even while venting visible gas, it barely drifted off its calculated path, gliding forward with uncanny precision, like a craft obeying hidden guidance. If it is only another comet, then science has no answers. If it is not, then we may have just witnessed our first interstellar visitor under intelligent control. That thought alone is enough to send a chill through even the most seasoned observers. For decades, scientists dreamed of hearing a faint signal, a coded invitation carried by radio waves. But in the silence of the cosmos, another channel has opened, one not of sound, but of substance. A body has crossed the gulf between stars, as if daring us to recognize it for what it might be. So we ask, what lies hidden behind these impossible signals, a natural anomaly or the echo of someone else's design? Tonight, on Lumora, we dive into the mystery of 3I/Atlas, the enigma that challenges the very limits of what we thought possible. For much of modern history, the search for other civilizations meant one thing: tuning in. Radio telescopes swept the skies for any pulse, any artificial rhythm hidden in the static of the universe. Decades passed with nothing but silence, and so SETI became a monument to patience. Yet the cosmos had its own plan. When Oumuamua streaked into the solar system in 2017, it shattered assumptions. No longer were scientists chasing only whispers of light or sound. Suddenly, the evidence might arrive in the form of a solid traveler. 2 years later came Borisov, its comet-like trail marking it clearly as natural. And then, as if the universe were escalating its puzzle, came 3I/Atlas. The odds against such arrivals are staggering. For every 100 billion comets bound to the sun, only 1 or 2 are thought to come from another star. That rarity means each detection is cosmic gold, a once-in-a-lifetime lottery ticket. And unlike fleeting radio bursts that fade in an instant, these interstellar objects are tangible, enduring. They can be measured, photographed, studied. They carry with them the memory of distant systems, dust, chemistry, trajectories carved by forces light years away. The possibility has transformed how astronomers think about techno-signatures. Perhaps the most enduring proof of life is not a broadcast at all, but something physical, a macroscopic artifact, silent yet persistent, still drifting long after its makers are gone. Unlike a signal, which dies with time, an object can outlive civilizations, carrying technology or even intent across eons. Every interstellar visitor is therefore more than a curiosity. It is a messenger, a witness from somewhere else, maybe even a relic left behind deliberately. This shift marks a turning point in humanity's watch over the skies. No longer is the search defined by what we might hear. It is also shaped by what we might see, passing through our cosmic backyard without warning. And in that silence, 3I/Atlas has become the loudest voice yet. On May 7, 2025, the Transiting Exoplanet Survey satellite, better known as TESS, captured a faint streak against the dense star fields near the galactic center. At first, it was nothing more than a whisper in the data, too subtle for automated alerts. Buried in digital clutter, the motion of the object went unnoticed. Night after night, TESS continued to record, stacking faint traces on its archival drives, each exposure like a puzzle piece waiting to be recognized. It wasn't until July 1st that the Atlas survey station in Chile flagged the anomaly. By then, the object had brightened sharply, 5 times more luminous than in May. Astronomers realized they had been watching a hidden traveler, one that had slipped through weeks of observations before it revealed itself. Within 24 hours, observatories around the world pivoted their instruments, racing to catch up. The discovery became a global detective story. Teams combed through archives from the Zwicky Transient Facility and Pan-STARRS, uncovering earlier images of Atlas from June. Amateur astronomers joined in, digging through public data, tracing the object's steady path across the sky. From June 14th to the end of the month, missing gaps were filled, and what emerged was a light curve rising in a way no simple geometry could explain. Part of the difficulty was Atlas's unfortunate position. It moved through Sagittarius, a region crowded with stars where transient objects are easily lost in the glare. Only after the July announcement did the full picture emerge. Thanks to a forensic sweep of terabytes of stored data, astronomers pieced together the story. Between May 7th and June 3rd, Atlas brightened fivefold, a surge that defied every expectation of how a comet should behave at such distances. It was no single moment of discovery, but a slow burn, a riddle hiding in plain sight until persistence brought it to light. And when it finally did, the world realized something extraordinary had entered our solar system. The first question astronomers asked was simple. Why did 3I Atlas shine so brightly, so quickly? Standard geometry offered no comfort. At a distance of over 6 astronomical units in May, far beyond the warmth where ice begins to sublimate, Atlas should have remained dim, quiet, and largely invisible. A modest rise in brightness, perhaps 1.5 times, would have been normal as sunlight reflected from its surface. But what telescopes recorded was 5 times that, a surge far too large to dismiss as chance. The numbers were carefully checked. Photometry from TESS, ZTF, and Atlas all aligned, each cross-calibrated against field stars and solar analogs. The systematics were small, less than a tenth of a magnitude. There was no error, no hidden fluke of background confusion. Night after night, the light curve drew a smooth arc, climbing steadily even as the object threaded through the galactic bulge. What made this all the more baffling was the timing. At such distances, comets do not normally wake. Water ice remains frozen, the sun's influence still faint. Yet Atlas already displayed a visible coma, its dust cross-section swelling from roughly 300 square kilometers in May to more than 1,700 by July. It was as though the object had ignored the rulebook, beginning its activity far earlier and far stronger than physics suggested. For astronomers, the implication was unsettling.
We just don't have enough time.
No single telescope could account for the magnitude of change. Taken together, the data forced a confrontation. Atlas was not behaving like any comet they had ever known. Either some unknown natural process was at work, or something far less ordinary was unfolding. Each new measurement added weight to the mystery. It wasn't an outburst, a fleeting flare, or a trick of instrumentation. It was consistent, relentless, and undeniable. 3I Atlas had already marked itself as an outlier before it even entered the official record. And from that moment on, nothing about its behavior would prove easy to explain. When the brightness refused to fit the models, scientists turned to explanation by elimination. First came the usual suspects: instrumental error, atmospheric distortion, or background confusion in the dense Sagittarius star fields. Each was tested, recalibrated, and ultimately discarded. The numbers held. The light curve was too smooth, too consistent across continents and telescopes. Something else was driving Atlas's glow. One theory suggested its velocity had been underestimated, hidden by the crowded backdrop of stars. Perhaps it was closer than it seemed, its true motion masked. But even after correcting for these effects, the excess brightness remained. Another possibility was chemical. Maybe exotic ices or compounds buried within the nucleus had begun to vaporize, releasing energy in ways rarely seen. Yet none of these ideas could account for the sheer scale of the brightening. That left the fringes of speculation. Could Atlas have slowed itself deliberately? If thrusters had fired, a controlled deceleration could explain both the excess light and the strange steadiness of its trajectory. An engineered braking maneuver, carried out far from the sun, would have mimicked the activity of a comet while avoiding the classic signs of outgassing. To many, this idea sounded more like science fiction than astrophysics, but the timing fit, and the possibility could not be dismissed outright. If Atlas were under intelligent control, then its early brightening might have been the visible echo of a decision made, not a random accident of nature. It would mean we were not watching a simple rock, but a vehicle, an interstellar visitor choosing how it moved through space. For every leap of imagination, though, there came a call for caution. The universe has a way of humbling even the boldest theories. Still, the debate had shifted. No longer was Atlas just a curious comet. It had become a canvas for humanity's most daring question. What if we were not alone? If the brightness and trajectory were already hard to explain, the chemical fingerprints of 3I Atlas deepened the riddle. Using the Very Large Telescope in Chile, astronomers tuned their spectrographs to catch the faintest atomic whispers in the coma. What they found left them unsettled. Clean, well-defined emission lines of nickel rose above the background, but iron, its eternal partner in cosmic chemistry, was nowhere to be found. This was unprecedented. In every known comet of our solar system, iron and nickel travel together, forged in the same ancient supernovae and carried in the same dusty cores. The Sun itself holds about 18 atoms of iron for every atom of nickel. Even the dustiest, most metal-rich comets rarely show nickel outpacing iron by more than a factor of 2. Yet here, the ratio wasn't just unusual, it was impossible. Nickel outstripped iron by factors of 15, perhaps even 50. The iron lines were buried so deep below the detection floor, they may as well not have existed. The research team rechecked everything: calibrations, atmospheric corrections, even laboratory references. Every test came back the same. Nickel was present, iron absent. Possible natural explanations were floated: exotic fractionation during planetesimal birth, selective sputtering from solar radiation, or the vaporization of fragile nickel carbonyl molecules. But none of these could fully account for the discrepancy. The more radical theories raised uncomfortable possibilities. Could these be traces of engineered alloys, eroded remnants of ancient engines or structures? Nickel-rich supermaterials, long since degraded, leaving behind a chemical echo of their purpose? It was speculation, yes, but the data refused to let the question go. There were no obvious propellant lines, no signature of familiar fuels, only nickel standing alone and the silence of iron. The elemental ledger was unbalanced, a mystery without precedent. For those willing to imagine, it looked less like geology and more like the residue of design. And so, the chemical puzzle of 3I Atlas became as strange as its light curve, another reason to doubt nature had the final word. If Atlas's chemistry was a paradox, its motion through space was an outright contradiction. Normally, comets act like rockets. As sunlight heats their icy surfaces, jets of vapor erupt, pushing the nucleus ever so slightly off its predicted path. This non-gravitational acceleration is a cornerstone of cometary physics. But with 3I Atlas, the math refused to cooperate. Astrometric fits from July through August showed a drift of just 1 to 1.5 kilometers per day, barely a nudge, despite its coma and tail stretching for hundreds of thousands of kilometers behind it. Borisov, the last interstellar comet, drifted by almost 100 kilometers per day under the push of its outgassing, exactly as physics would predict. Oumuamua, by contrast, showed the opposite puzzle. No visible coma, no dust, yet it veered sharply near perihelion with a trajectory shift of tens of thousands of kilometers. Atlas seemed to combine both mysteries in reverse. Its coma was undeniable, its dust cloud vast, its jets visible in images. And yet its orbit remained stubbornly pure, as if untouched by the forces visibly streaming from its surface. Models that accounted for the observed mass loss predicted a much larger deviation. Instead, the object glided on, immune to the very activity that should have pushed it aside. If Atlas were nothing more than rock and ice, the only natural explanation would be mass, something so dense and immense that even powerful jets could barely move it. But photometry and brightness profiles ruled out such an enormous size. That left only speculation, active stabilization, hidden control, or a design that redirected thrust in ways no natural body could. The contradiction was mechanical as much as mathematical. In the language of physics, mass and force must dictate motion. Here, the rules bent. Atlas behaved as though guided by an unseen hand, its path unwavering even in the face of chaos. For many watching, it was impossible not to wonder if control, not chance, was steering this visitor through our solar system. From the moment it revealed itself, 3I Atlas has stood as a challenge to everything we thought we understood about the cosmos. Its five-fold surge in brightness, its coma rich with nickel yet barren of iron, its trajectory almost untouched by the very jets that should have pushed it astray. Each detail adds a new piece to a puzzle that refuses to resolve. Other interstellar visitors set the stage. Borisov behaved like a comet should, its physics obedient to every calculation. Oumuamua did the opposite, veering wildly without leaving so much as a wisp of dust. And now Atlas, the third entry in this cosmic trilogy, defies expectation again, bright, active, and yet stubbornly steady in its motion. 3 anomalies, 3 different rules broken, as if the universe is dealing us wild cards one after another. Around the globe, both professionals and amateurs have risen to the challenge. From the massive mirrors of observatories to backyard telescopes connected by open-source software, a network of eyes tracks Atlas nightly. Each image shrinks the uncertainties, each spectrum adds to the ledger of contradictions. Early warnings ripple across Discord servers and Telegram groups as communities mobilize to follow every flicker of light. In this new era, discovery is no longer the domain of professionals alone. It belongs to anyone willing to watch the sky. And yet, for all the data gathered, one truth remains. Nothing we know fully explains 3I Atlas. No natural model accounts for all its strangeness, but no definitive evidence proves artificial intent either. It hovers between categories, a messenger without a clear message, a riddle written in chemistry and motion. Perhaps that is the lesson, that not all answers arrive in the form of signals or words. Sometimes the most profound communication is silence, the steady passing of an object that forces us to ask if we are truly alone. As Atlas drifts on, humanity is left with wonder, unease, and the realization that the universe may be far stranger than we dare to believe. And here on Lumora, we will keep following that wonder, watching the skies, and sharing with you every sign, every whisper that suggests we are not the only ones writing stories among the stars.